Welcome, guys. Welcome to this aptitude training session brought to you by Six Phrase, the finishing school. My name is Saravana Kumar, and I'm the resident aptitude training instructor for the finishing school, all of the country. Okay, now let us get into today's session. Now, in today's session, we'll be starting quants series, number systems. Um, I would like you to go through this table of contents where we'll be today it is numbers, and slowly we'll be looking at other topics also. So we start with numbers, and then we go to problems in HCF and LCM. Then we get into percentages. Percentages is very important because without understanding the concept of percentages, you cannot move forward and look at profit and loss or say simple interest component, because it is impossible to look at those topics without having an understanding of percentages. Okay, so then comes averages. Without knowing what is averages, you cannot know what is allegations and mixture. So there is a reason why we put this order. Okay, uh, so then we get into time and work, permutation combination. Without knowing what is permutation combination, we cannot know what is probability. So all this are layered. So we layer the syllabus inside in that order. Now today's topic is numbers. As you know, in quants, the founding uh, blocks, or I should say, the building blocks of numbers. The building blocks of quants is numbers, digits. So without knowing things about numbers and digits, we cannot move forward and learn advanced concepts like percentages, profit and loss, permutation, combination. Those advanced concepts won't be possible without you guys understanding the foundation or founding concepts. So I thought we'll start with reminders. So today we are going to look at reminders. Now, what is a reminder? Now, just think about what is a reminder. Okay. Now, in order to tell you what a reminder is, I'd like you to assume you have 53 chocolates. Okay. You hold in your hand right now 53 chocolates, and you have to divide them equally between 10 children without breaking it. Okay. You are not allowed to break the chocolates. Okay. Now you have to divide them equally between 10 children, and you have to distribute the maximum number of chocolates. Okay, as much as possible, you will have to distribute the maximum number of chocolates to them. Okay, now how would you do it? So let's think about it. Pause the video. I want you to pause the video, think about it, and then we'll move on. Now, I hope you paused the video and thought about it. And most of you would agree with me. It will be done like this. Yes, for 10 children, 53 chocolates would be divided in this way. Okay, so a total of 50 chocolates would be distributed. Okay, out of 53 that you have in your hands, 50 chocolates would have been distributed. Now, will you have any chocolates remaining in your hands? Of course, yes. You have. So you had 53. You gave away 50. So what do you have? You have 3 left, right? Now, in this whole thing of 53 chocolates of 10 children and dividing it equally among them, and then the remaining 3 chocolates, all this tell you something. Okay, this 10 children are the divisors. This 53 chocolates that you initially had, okay, it is the dividend. The quotient 5 is the maximum amount of chocolates that each children got at the end. Okay, and the remainder is the number of chocolates you finally had which you were unable to distribute. Okay, so the remainder is 3. So this is how you understand divisor, dividend, quotient and remainder in a real sense or in a real life scenario. Because by understanding it this way, what you're doing is you're understanding how these concepts are applied in day-to-day activities. Mathematics is there everywhere. Okay, so I'd like to point out an example where you heard about this Fibonacci series, right? you'll find this Fibonacci series everywhere in nature. Okay, those numbers you'll find it in nature. You'll find it in the rings in when you cut open a fruit. You'll find rings inside the fruit, right? Those rings will be according to the Fibonacci series. So all of mathematics, if you look closely, you'll find it in your real life. If you look real closely, okay. So most of these videos, what we'll try to do is we'll try to relate the mathematics concepts that you learn here, and relate it to real life scenarios, like whatever you are doing in real life. Okay. For example, the 53 chocolate example is like that. Okay, you might come across many examples like that. Okay, because I want you to relate it by, if you relate it to things that you see daily or hear about daily. If you can relate it to things that you read daily, okay, or real world things, then you'll never forget it. Okay, so that is why I want you to understand divisor, dividend, quotient, remainder like this. Okay, so now I hope you got it. Now, let us get deep inside reminders and really understand what are reminders. Okay. Now, just look at these questions. Divide 14 by 6, divide 91 by 7, divide 43 by 3, divide 18 by 27, divide 14 by 15. Now, all these things, superficially, if you look at it, okay, on the outside, if you look at it, they may all seem, they may all belong, you may seem like they belong to the same category. Okay, but they don't. Okay, the first three things, this category, this problem, the second problem, the third problem, okay, these three problems is different from the last two. Okay, can you spot why? Can you tell why it is like that? The first three problems is different from the last two problems. How is it? Why is it? Okay, so you would have seen in the first three problems the dividend, okay, 14, 91, 43, these are all dividends. These dividends are greater than the divisors. 6, 7, 3. What are 6, 7, 3? They are the divisors. Yes. So in the first three problems, the dividend is greater than the divisor. Okay. But in the last two, if you have a close look, the dividend is less than the divisor. 18 is less than 27. Yes. 14 is less than 15. Yes. So here in the first three problems, the dividend is greater than the divisor. In the last two problems, the dividend is less than the divisor. Okay. So there is a difference. Okay. Okay. Let us see if you are able to answer this. Divide 14 by 6. What is the remainder? If you said 2, you are right. Okay. Because it is 2. Divide 91 by 7. What is the remainder? Yes, it is 0. Divide 43 by 3. It is 1. Okay. Now divide 18 by 27. What is the remainder? Divide 18 by 27. What is the remainder? It is 18. Divide 14 by 15. What is the remainder? It is 14. Okay. Now here what you'll have to watch carefully is, here you have the dividend to be 18 and the remainder also as 18. Here you have the dividend to be 14 and the remainder also to be 14. But that is not the case in the first three questions. Am I right? In the first three questions, the dividend and the remainder were not the same. 14, 2, not the same. 91, 0, not the same. 43, 1, not the same. But in the last two questions, if we have a look, 18 and 18, same. 14 and 14, same. Okay, so here dividend is equal to the remainder whenever the dividend is less than the divisor. Okay, so this is the most important concept you will have to understand. When divisor is more than the dividend, okay, dividend becomes the remainder. Okay, so make sure that you understand this very carefully because we'll be using this in problems. Okay, so we'll move on. Range of the reminders. Okay, now often I ask this question to students I tell them the divisor is 6. What could be the remainders? What could be the possible? What is the possibility of remainders? Okay, what are the possible remainders that you can come up with? I ask them. Okay, for that they say some of them say 7, some of them say 23, some of them say 0, some of them say 6. Okay, now out of these replies, 7, okay, they are close, 23, not even close, okay, 0, okay, they know something, okay, 6, they are very close, okay. So all these kinds of, I wouldn't say this is wrong, this is right, but you have to understand, for a number to be a divisor, okay, you have to clearly make a distinction of what is the range of the remainder. When I tell you a divisor, the next thing that should pop up in your mind is the range of the remainder. Okay, so when I tell you 6, okay, the range of the remainder, what is the range of the remainder? Okay, so you should come up with that. Okay, so similarly for divisor 122, for 55 and divisor 1, we'll have a look. Okay, for 6, there will be total 6 remainders, and it starts from 0 and it ends in 5. Okay, so for 6, which is the divisor, there will be 6 remainders. It starts from 0 and ends in 5. This is the range. Okay, 6 cannot be the remainder for the divisor 6. 21 cannot be the remainder for the divisor 6. Okay, 23 cannot be the remainder. 0 can be the remainder. Okay, so next for 122, there will be 122 remainders, or I should, so more appropriately, it is 122 possible remainders. Okay, so it starts from 0 and goes to 121. For divisor 55, again you will have 55 remainders. It starts from 0 and goes up until 54. And for the divisor 1, you will have one remainder, and it is 0 and only 0. The reason is you can divide any number by 1, right? All numbers are divisible by 1. So you'll never get a remainder other than 0. Okay. So if you've been like closely watching this pattern, the pattern is for divisor n, there will be n remainders and the range is 0 to n minus 1. Okay. So this concept, make sure that you understand it. This and the previous one that I talked about, when the divisor is greater than the dividend, you always find that the dividend is the remainder. Okay, so make sure that you get this. Now this is Spanish. If you think like you don't understand what they're talking about, I will give you a proper description for this. Dividendo is dividend. Okay, divisor is, divisor. Quotient is, they're talking about the quotient. Resto is remainder. Okay, so you can clearly see they've given you the formula relating all the 4 things that we saw in the previous slide. Yes, I told you what is dividend. Okay, remember dividend. Okay, 53. Remember divisor. Yes, it was 10. Remember quotient, it was 5. Remember remainder, it was 3, right? So similarly, they given relationship between these 4 variables, and you can see dividend is equal to divisor into quotient plus remainder. Okay, what is 6 into 7? Divisor into quotient. 6 into 7 is 42. 42 plus 5 is 47. Okay, so if you have to give you a clear example of this, again you have 8,475, which is the dividend, 23, which is the divisor. You divide this dividend by 23, you will get a quotient of 368 and a remainder of 11. Okay, so this is the dividend, which is equal to 368, which is the quotient, into divisor plus the remainder. Okay, so in general you can say dividend is equal to quotient into divisor plus remainder. Okay, you have to know this to solve problems in remainder. It is very important. Okay, now the next thing is we'll start with some problems. Okay, remainder when 2 power 35 is divided by 5. Okay, this is a proper remainder problem which often gets asked in many company questions. I've seen this in many company question papers, okay, both service and product companies. Okay, so make sure that you understand this question very carefully. Okay, reminder, when 2 power 35 is divided by 5. Okay, now the first step in this is, in all these types of problems, the first thing that you do is, you don't know what is 2 power 35 divided by 5. Okay, or to be more specific, you don't know what the remainder of 2 power 35 divided by 5 is. Okay, remainder of 2 power 35 by 5, you don't know what it is, but you can find the remainder of 2 power 1 by 5. That is easy to do. Yes, remainder of 2 power 1 divided by 5. That is easy to do, right? Yes. Just now I told you something about dividend being less than the divisor. Yes. So if the dividend is less than the divisor, here the dividend, what is the dividend here? It is 2 power 1. 2 power 1 is nothing but 2. Here the dividend is less than the divisor. So in the end, what do you get? You get a remainder which is equal to the dividend. Okay, so you get a remainder which is equal to the dividend. So you can see this 2 and this 2 will be equal, because the dividend, which is 2, is less than the divisor. Okay, so 2 power 1 divided by 5, the remainder of 2 power 1 divided by 5, the remainder is 2. Okay, now the remainder of 2 square divided by 5. Now how do you find this? Again, the dividend, what is the dividend here? 2 square. What is 2 square? 2 square is 4. Here the dividend is, again, 4 is less than 5, which is the divisor. So the dividend is less than the divisor. So again, you can use this dividend as the remainder. The remainder and the dividend will be the same. Okay, so 4 is the remainder in this case. Next, 2 cube. Okay, now 2 cube divided by 5. Now here you cannot use the principle of where dividend is less than the divisor, because what is 2 cube? 2 cube is 8, right? So 8 divided by 5, what is the remainder of 8 divided by 5? 8 divided by 5, it is 3. Okay, so that is the answer. Now next, 2 power 4 by 5. What is 2 power 4? It is 16 divided by 5. So 16 divided by 5, what is the remainder? It is 1. Okay, guys, this is a very important point. Okay, so what is it that I'm doing? If you pay close attention to what I'm doing here, I'm finding the remainders of 2 power 1 divided by 5, 2 square divided by 5, 2 cube divided by 5, 2 power 4 divided by 5. I keep increasing the power by 1. Yes, can you see that? I keep increasing the power of 2 by 1 each time. Okay, and I continue to do this until I get a 1. Okay, I continue to do this until I get a 1. Okay, now shall I ask you a question? Why do I use or increment the power of 2? Why is it that the base here is 2? Because in the question the base is 2. Okay, because here the base is 2, we are using the base here to be 2. Okay, because what you can see here is 2 4 3 1. Now if I do the next one, 2 power 5 divided by 5, what do you think will be the answer? 2 power 5 divided by 5 will again be 2. Okay, 2 power 6 divided by 5. Okay, I should say remainder of 2 power 6 divided by 5 will be 4. Remainder of 2 power 7 divided by 5 will be 3. Remainder of 2 power 8 divided by 5 will be 1. Okay, so this cycle keeps repeating. Okay, and the interval is 4. Okay, once every 4 numbers, this cycle keeps repeating, right? 2 4 3 1, 2 4 3 1, 2 4 3 1. Once you reach this 1, again it will be 2 4 3 1. So you have to look for this number 1. Okay, so whenever you get this number 1, then your cycle is complete. Okay, in this case the cycle is 4, so that's why the cyclicity it says is 4. Sometimes it will end at the second position. Okay, then the cyclicity is 2, or you will get 1 here itself. Okay, sometimes you will get 1 here, it means cyclicity is 3. Sometimes like in this case you will get here. Sometimes you may get 1 in the fifth position, their cyclicity is 5. Sometimes you may get 1 in the sixth position, their cyclicity is 6. Okay, so depending upon that we do some calculations. Okay, now Now you understood that the cyclicity here is 4. Now how do you find the remainder for 2 power 35 divided by 5? Now how do you do it? It is very simple, the last step. Now let us suppose instead of 35 you had 33. Okay, here the power of 2 is 35. So let us suppose instead of 35 you had 33 as the power. Okay, now 33 divided by 4, what is the remainder? It is 1. Right now, why did I divide it by 4? Because the cyclicity is 4. Because the cyclicity is 4, this pattern repeats every fourth number. Okay, that is why I divide this by 4. Okay. Now 33 divided by 4 is, the remainder is 1. Okay. Can you spot the yellow colored box? Yes. So this means when you get the remainder to be 1, this means we are dealing with this category. Okay, 2 power 1 category. Okay, 2 power 1 and 2 power 33 are will give you the same remainders. Okay, that is the meaning. 2 power 1 and 2 power 33 will give you the same remainders. So for 2 power 33 divided by 4, so 2 power 33, the remainder is 1. 2 power 1 divided by 5, the remainder will be 2, right? Yes, for 2 power 33, it says the remainder is 1. So the remainder is 1. Similarly, here 2 power 3, what remainder 1 indicates is, it indicates that 2 power 33 is the same as 2 power 1. Okay, 34, let us take 34 divided by 4. What do you get? Remainder 2. So this remainder indicates that 2 power 34 is the same as 2 square. Okay, so next is 35 divided by 4. That is what we've been given in the question. 35 divided by 4. Okay, so remainder is 3. So it means we belong to this category. Okay, third category. Okay, red color. Okay, the colors match. Okay, 36 divided by 4. Remainder is 0. It means again we belong to this category. Okay, so when the remainder is 1, your answer is 2. Okay, when the remainder is 2, your answer is 4. When the remainder is 3, your answer is 3. And when the remainder is 0, your answer is 1. Okay, so whenever you are given a power, what you do is just divide it by 4. Okay, divide it by 4. Look at what you get as the remainder. Depending upon what remainder you get, your answer will vary between 2, 4, 3 and 1. Okay, so it is as simple as that. And this 4 is dependent upon the cyclicity. If the cyclicity is 6, you have to divide this power by what? 6. The cyclicity is 7, you have to divide this number by 7. Okay, so we'll do more problems in this so that you get an understanding of what we are actually doing here. Okay, to put it in a nutshell, what we are doing is, we cannot find the remainder of 2 power 35 by 5 directly. Okay, but what we can do is, we identify the pattern, because every uh, 2 power 1, 2 power 2, 2 power 5, you divide it by it, the remainders will always give you patterns. Okay, so you make sure you understand this pattern, and depending upon that, you can solve this problem. Okay, so we'll move on to the next one. Yes, you can see 2 power 35 by 5, answer is 3. It is red color, so it belongs to this category. Okay, because the remainder is 3, it belongs to this category. Okay, now how do we say 30 is divisible by 6? Yes, I want you to pause this video again and then think about it. How do we say, or why do we say 30 is divisible by 6? Okay, now pause the video. I hope you paused the video and thought about it. Okay, now you would have come up with an answer. So let's check if what you thought is right or wrong. Okay, now the common answer that I always get is this. Okay, can you guess the common answer? Okay, no need. We'll move on. Yes, this is the common answer. This may look funny for some people, but this is the answer that I get 95% of the time. How do we say 30 is divisible by 6? For that, the answer that I get is because 6 can divide 30. Yes, this is very simple, right? Yes, how do we say 30 is divisible by 6? The common answer is because 6 can divide 30. Now tell me, Is this an answer for my question? Is this an appropriate answer for my question? Obviously not. I'm asking the reason. Okay, what is the reason 30 is divisible by 6? Okay, now you are telling me 30 is divisible by 6 because 6 can divide 30. Okay, uh, it is like me asking you why you did not come to college yesterday. Now your reply is, I did not come to college yesterday because I did not come to college yesterday. Now, how does this answer look like? Okay, so that is how this answer looks to me. Okay, so the correct answer, yes, you just, if you have some uh, funny bone inside of yourself, then take a look at this. They don't know that we know that they know. Okay, I hope you understand what I meant by that. Okay, okay, the correct answer is, see, 30 is a product of 5 and 6. Okay, I could write 30 as 5 into 6. Yes or no? Yes, right? 30 can be written as 5 into 6. Okay, because you write it as a product of 5 and 6, you can divide it by 5 or you can divide it by 6, right? So this is the reason why 5 and 6 are the most obvious factors, okay, or 5 and 6 are the most obvious divisors of 30. Okay, there are other divisors. Yes, 10 can divide 30. Yes, 15 can divide 30. Yes, 3 can divide 30, 2 can divide 30. Okay, but 5 and 6 are obvious devices of factors, or the reason is, you can directly see 30 is a product of 5 and 6. Okay, so you can you can say 30 is divisible by 6, or you can say 30 is divisible by 5. Okay, so this is the reason why we say that. Okay. Now, when 7 power 35 is divided by 5, the remainder is. Okay. Now, what do we do? You know the drill. Okay. The first thing is, you start with 7 power 1 divided by 5. You start with 7 power 1 divided by 5. The remainder is 2. Yes, right, guys. Next, you do remainder of 7 square divided by 5. What is 7 square divided by 5? 7 square is 49, right? 49 divided by 5, the remainder is 4. Okay, so that is why you have 4 here. Okay, now the next one, 7 cube divided by 5. Guys, this is where it gets tricky, or it gets difficult. Now, some of you might know 7 cube is 343. Okay, now, but not everybody knows it. Okay, 343 divided by 5, you will get 3 as the remainder. Okay, now 7 power 4 divided by 5, it gets even difficult. Okay, 7 power 4 divided by 5 is, so what is 7 power 4? Okay, very few people know what is 7 power 4. Okay, it is 343 into 7. Okay, so this is where this helps. Okay, now what I am pointing in this red laser is the shortcut in which you can avoid calculating 7 cube, 7 4, 7 power 5, 7 power 6. You don't need to calculate it, just use this shortcut. Okay, now what you do is, take this 7. Okay, now you got this 3 here, right? I'll tell you how you got this 3. Okay, in an easier way. You don't need to calculate 7 cube. Okay, what you need to do is, take the 7, multiply it with 4. What will happen? 7 into 4 is 28. Now divide it by 5, get the remainder. Now if you divide this by 5, you'll get the remainder to be 3. This 3 is this 3. That is why you see both of these 3's in black color. Okay, this 3 is this 3. Now again, for the next one, you don't need to find 7 power 4. Okay, not at all needed. What do you do? Take this 7, multiply it with this 3. What do you get? 21. So you get this 21. Now what is the remainder of 21 by 5? You get it to be 1. Okay, this one is this one. So just put this value here. Okay, so that is why, again, they color correspond. They both are red in color. Okay, for the next one, 7 power 5, 7 power 6, 7 power 7, 7 power 8. Easy to find, you think? No, right? So that is why you have to use this method. Okay, for 7 power 5, what you do is take the 7, multiply it by 1, what do you get? 7, right? So remainder of 7 by 5 is 2. Okay, guys, I've told you, if you remember it, okay, once you get this one, you can stop it then and there. Okay, but I still proceeded it with 7 power 5 to show you how it repeats, how this remainder repeats. Okay, so you can see after this one, again for 7 power 5, it is 2. This 2 came about because I used this answer. Okay, shortcut. Okay, now again, how do I get for 7 power 6 divided by 5? Take this 7, multiply it by 2, you will get 14. So you will get 4. This 4, put it here. Okay, so that's it. You don't need to find 7 power 6. Not at all required. Okay, now how do you find 7 power 7? Take this 7, multiply it by 4, you will get 28 divided by 5. The remainder, when 28 divided by 5 is 3, put the 3 here. You don't need to find 7 power 7. Now 7 power 8, how do you find the remainder of 7 power 8 divided by 5? Take this 7, multiply it by 5, you will get, take this 7, multiply it by 3, you will get 21. Okay, the remainder of 21 by 5 is 1. Put that 1 here. Okay, guys, can you see this pattern? 2, 4, 3, 1. Again 2, 4, 3, 1. So what will be 7 remainder of 7 power 9 divided by 5? 2, 4, 3, 1. What will be the remainder of 7 power 10 divided by 5? 2, 4, 3, 1. Okay. Now, some of you, if you listen to this very carefully, 2 slides ago, we saw 2 power 35, remainder of 2 power 35 divided by 5. Yes, we remember it. 2 slides ago, we saw the remainder of 2 power 35 divided by 5. That problem. Okay. Now, it is funny. You can see you have the same pattern here also. 2431, 2431, 2431. Okay, even in that question you had 2431, 2431, 2431. Does it suggest that both remainders of 7 power 35 by 5 and remainder of 2 power 35 by 5 are the same? See, for not one moment I am suggesting 7 power 35 by 5 is equal to 2 power 35 by 5. Okay, that is not what I am saying. What I am saying is remainders of 7 power 35 by 5 is equal to the remainder of 2 power 35 by 5. That is what I am suggesting. Okay. Yes, it is true, because if you divide 7 by 5, what do you get? Take this 7, take this 5, divide it. What is the remainder? 2, right? That 2 you put it here. Okay, that is remainder theorem. Okay, so yes, it is true. Remainder of 7 power 35 by 5 is the same as the remainder of 2 power 35 by 5. Okay, so I don't know if you noticed this. There is something called did you know? Okay, just have a look at this. Okay, next one. Find the remainder when 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4 is divided by 16. To understand this problem, you will have to understand these things. Okay, what are these things? 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16. Can anyone tell me what is the divisibility check for 2? What is the divisibility check for 2? For the number 2, or I should say, digit or number 2. The divisibility check is if the last digit, okay, last one digit is divisible by 2, the whole number is divisible by 2. What is the divisibility check for 4? If the last two digits is divisible by 4, the whole number is divisible by 4. Okay, the given number is divisible by 4. Okay, what is the divisibility check for 8? If the last three digits is divisible by 8, the given number is divisible by 8. What is the divisibility check for 16? If the last four digits is divisible by 16, the given number is divisible by 16. I hope you know what is the divisibility check for 32. I hope you know or understand what is the divisibility check for 64. Okay. Okay. So now let us take this number 16, 16 for example. Is 16, 16 divisible by 2? How do you know? Look for this digit. Okay. See if it is divisible by 2. Then the whole number is divisible by 2. Okay. Is 16, 16 divisible by 4? Look for these two digits. See if it is divisible by 4. If it is divisible by 4, the whole number is divisible by 4. Is 1616 divisible by 8? Look for these last 3 digits. See if it is divisible by 8. Then it is divisible by, the whole given number is divisible by 8. Okay. 1616 divisible by 16. Look for all the 4 digits. See if it is divisible by 16. Then the given number is divisible by 16. Okay. So guys, for this question, if you have to know if this number is divisible by 16, what should you do? You must take the last 4 digits and check if it is divisible by 16. Okay. Or take the last 4 digits, divide it by 16. Whatever you get as the remainder is your final answer. Okay, so that is what we are doing. Take the last 4 digits, 1 2 3 4. So 1 2 3 4 divided by 16. So finally you will get a remainder of 2, which is the answer. A number when divided by 259 leaves a remainder 139. What will be the remainder when the same number is divided by 37? Okay, so I'll just read the question again. So the question is very simple. Okay, you divide a number, we don't know what that number is. You divide that number or by 259. You get a remainder of 139. Okay, what will be the remainder when the same number is divided by 37? Guys, now you tell me what is the dividend in this question? What is the dividend in this question? Yes, if you correctly guessed it, okay, that is what we are going to find. Okay, that is what is not given in the question. Dividend is what we are going to find. It is not given in the question. Okay, but what is given is two divisors. Okay, one of the divisor is 259, the second divisor is 37. The first divisor is 259, the second divisor is 37. Okay, the dividend is not given. Okay, that is what you have to find. If you divide the dividend by 259, the remainder that you get is 139. Okay, if you divide the same dividend by 37, what is the remainder that you will get? Okay, so if I ask you, what is the first number which leaves a remainder of 139 when divided by 259? Okay, when you divide a number by 259, what is the first number which, when divided by 259, will give you a remainder of 139? Okay, so first number, any guesses? Yes, most of you would say it is 259 plus 139, right? I guess it would come out around 398. Okay, so 398 is more or less correct. Yes, that is the first number which is divisible by 259, but that is not actually true. Okay, that is 398 is not the first number which, when divided by 259, will give you a remainder of 139. I'll tell you what the first number is. Okay. Yes, you are wrong if you said 259 plus 139. Okay, it is actually 139. Yes. Now, guys, this is where you apply what I teach. Okay, what did I tell you? Okay, I told you when the dividend is less than the divisor, what is the remainder? The dividend becomes the remainder. Yes, so 139 could be the possible dividend. Yes, and it is also the smallest dividend which you can use. Yes, the first and the smallest dividend, which when divided by 259 will give you 139, is 139. Okay, because 139 divided by 259 will give you a remainder of 139. Here the dividend is less than the divisor, so obviously the dividend becomes the remainder. Okay, now it is very easy. What do? You know what the dividend is. Divide this 139 by the second divisor 37, you will get a remainder of 28. Okay, so that is the answer. Remainder when 23 power 34 is divided by 24. Okay, so by now I hope you guys know how to do these types of problems. Okay, so very easy one. 23 power 34 is divided by 24. The first step, what is the first step? So 2 power 35, that problem how did you do? You started by finding the remainder of 2 power 1 by 5. 7 power 35, how did you do? You started by finding the remainder of 7 power 1. So here it is 23 power 34. So you start by 23 power 1 divided by 24. So the remainder of 23 power 1 divided by 24 is 23. 23 square divided by 24. Okay, 23 square, guys, is 529. Okay, so when you divide that by 24, you will get a remainder of 1. Okay, so now what do you see? Once you get 1, what do? You stop, because again for 23 cube divided by 24, what will be your answer? It is going to be 23. Okay, 23 power 4 divided by 24, the remainder is going to be 1. So 23 and 1 are going to alternate. For all the odd powers of 23 divided by 24, the remainder will be 23. For all the even powers of 23 divided by 24, okay, 23 square, 24, 3 power 4, 23 power 6, okay. For all this, the remainder is going to be 1, okay. So here you tell me, is it odd power or even power? 34 is even power. So what is the answer? The answer is 1. It is as simple as that. Okay. So the answer is 1. Okay. Guys, you have an alert. Okay. So what this alert means is, you'll have to listen and understand here very carefully. Okay. There is an alert because there is another way you can do this problem. Okay, where I'll have to introduce to you a concept called negative reminders. Okay, there is a spelling mistake. Okay, these people who make this videos, they make these mistakes. So I'll have to tell them negative reminders. Okay, these negative reminders. Now, some of you might ask, I never talked about a negative reminder. You remember my first slide? Yes. In that I said the range is from 0 to 5. The range is from 0 to 7. I was telling you the range is from 0 to 122. The range is from 0, 0, 0. There was no negative numbers there. Okay. So how come this concept of negative reminders came about? Okay. Guys, there is actually, reminders cannot be negative. Okay. But for the sake of solving problems, we assume reminders to be negative. Okay, for the sake of solving problems easily, yes, you can solve this problem like this, but there is an easier way of solving this problem. Okay, for that, for the sake of solving problems, you assume reminders to be negative. Okay, so I'll tell you how, why and how. It is very simple. Okay, now 10 divided by 7, what is the remainder, guys? 3. Yes, if you divide 10 by 7, the remainder is 3. Okay, but if I have to find the negative remainder of this, okay, what I'll do is, I'll move, see, this 3 I got because I moved from 7 3 places to go to 10. Yes, from 7 you move 3 places, you go to 10. Okay, so that is how this 3 I got. Okay, now what I'll do is, I'll, instead of moving forward, I'll move backward like this. Okay, from 7, how many places if I go will I get 3? 4 places. Yes, so that is why I get a negative 4 here. Okay, instead of going forward, I'm going backward. Okay, if I go backward, I go into the negative space. So from here to here it is plus 3. From here to here it is minus 4. Okay, so by finding the positive remainder, you also find the negative remainder. Okay, so take this for example, 44 divided by 12. Okay, so from, you divide this by 12, what do you get? You get 8. Yes, from 36, guys, if 12 3 times is 36, so from 36 to 44, if you go, you have to move 8 places, right? But if you have to go backwards like this, how much places you should go? You should go 12 minus 8 is 4. So again it is minus 4. Okay. Again look at this. 14 6 times is 84. So instead of 14 you can substitute 84 here. Okay. Here it is 84. From 84 if you go 7 places forward you get 91. Okay. That is why we have a 7 here. Okay. 14 into 6 is 84. You cannot have 14 into 7 because it will be 98, which is greater than 91. Okay. So you get 14 into 6, which is 84. From 84, you move 7 spaces forward. Okay, so that is where you get the 7. Now, how do you get the negative remainder? From 14, you go how many spaces backwards to go to 7? You will have to go 7 spaces back. 14 minus 7 is 7, right? So, minus 7. Okay, so one final example, we'll take 112 and 10. 10 11 times this, guys, 110. Okay, so from 110 to 112, how many spaces? 2 spaces, right? So that is why from here to here it is 2. Okay, from 10 to 2, how many spaces should I go backwards? From 10 to 2, I should go 8 spaces backwards. Yes, or 8 places backwards, right? So minus 8. Okay, the thing for you to note, so you can either say the remainder of 112 by 10, you can either say it to be 2 or minus 8. Both are correct. Okay, 91 by 14, what is the remainder? You can say 7 or minus 7. Both are correct. Okay, 44 by 12, the remainder is 8 or minus 4. And 10 by 7, the remainder is 3 or minus 4. All these are what we call as negative remainders, which is equivalent to these positive remainders. Okay, if you can use this or use this in problems to solve. Okay, both are the same things. Now, add, if you want to double check it, okay, sometimes in problems, having negative reminders is not good. Okay, so we won't arrive at the result or arrive at what we are looking for. Okay, or arrive at our conclusion. Okay, so usually when we get a negative reminder, what people do is they at that instant they change it into positive reminders. The way you change this negative reminder into positive reminder is very simple. Okay, take this number, add the divisor to this. Okay, minus 4 plus 7, you will get 3. So you can see minus 4 has changed into 3. Okay, how do you change minus 4 into the positive remainder? Add 12 to it. Minus 4 plus 12. Okay, you have to add this to this negative remainder, add the divisor. Okay, to this negative remainder, add the divisor, you will get this positive remainder. It is not advisable to have negative remainders in some problems. That is the reason. Okay, so minus 7 plus 14, what do you get? You get 7. Minus 8 plus 1 plus 10, you get 2. Okay, so this is how you change negative remainders to positive remainders. Now, why did I talk about negative remainders? This problem can be solved using negative reminders. Okay, because if you use negative reminders, you don't need to do 23 square, which is a difficult thing to do. I understand. 23 square, 529, not everybody knows it. Okay, so we can avoid that if you know this method. Okay, so I want to make sure you understand, you know all the shortcuts, all the nitty-gritties of reminders. Okay, this reminders program is a comprehensive program which covers all the details in reminders, so that whenever you are asked a question in reminders, you don't like uh, you don't feel you are inadequately prepared. Okay, okay, so we'll see how to use this in this problem. Okay, now guys, you know the remainder of 23 divided by 24 is equal to 23. Okay, but this 23 is what we call as positive remainder. What is a negative remainder for this? What is the negative remainder for this? We just now found it here. Now, how did I go to the negative remainder? From this, I went 4 steps backwards. Okay. Yes, from this divisor, I went 4 steps backwards. So, from this divisor, how many steps backwards should I need to go here? 1 step, right? So, the negative remainder is nothing but minus 1. Okay. So, the remainder of 23 power 1 divided by 4 is nothing but minus 1. So, what I am doing is, I am very conveniently writing 23 as minus 1. Okay, because instead of 23 here, what do I get? Minus 1. I told you, right? 3 minus 4 are the same things. 8 minus 4 are the same things. 7 minus 7 are the same things. So similarly, 23 and minus 1 are the same things. This is the positive remainder. This is the negative remainder. So instead of 23, I write minus 1. What is minus 1 power 34? Is what is minus 1 power even power? Minus 1 the whole even power. It is plus 1, right? So 1 divided by 24, your answer is 1. So did we get the same answer? we got the same answer, sans 23 square. Okay, sans meaning without knowing what is 23 square. Okay, and did you know 215 are the only prime numbers that end in 215? Well, something to think about. Okay, okay, guys. So I hope that was useful. Okay, we'll meet in another video. Thank you.